this video, I'll talk about a Benedict test solution. So how do I know if a Benedict test is going to be a positive or it's going to be negative, and what particular type of function groups gives you a positive Benedict test and what particular types of function groups gives you a negative Benedict test. So to begin with, it's really the aldehyde function groups that actually gives you a positive Benedict's test. And if you have a ketone, that will give you a negative Benedict test. Now, how do I know whether it's going to be, how does it really look like in terms of appearance? So, and also like what type of chemicals we're really using in this. So suppose if I have in a generic aldehyde function group in a compound, and we are using copper in there that has a 2 plus charge. So typically copper sulfate, stuff like those. So copper sulfate or copper 2 plus originally is usually blue in color. So it's a blue in color, and if it does oxidize the aldehyde to make it an acid at the end of the day, like in this case, aldehyde gets converted to an acid, then this copper is going to be the one that's actually going to get reduced. And so you ended up making Cu2O here. So this copper, when it's Cu2O, it actually has an oxidation number of +1. So you can kind of see how it's going from +2 to +1. So that means this is undergoing a reduction. Now, if that happens, this copper solution, when it has a positive, it will change its color to something else. Typically, that color in this particular case is going to be red color. This is this guy right there. Now, if you do have some sort of positive test or some sort of sugar, like, or in this case, it has an aldehyde function group, and if it does get converted to an acid, or if it maybe it does not have a lot, or maybe has a trace amount in there, or if it does not have a super high concentration, stuff like this, then it will still change the color. So you can kind of see how it kind of gets converted to a green, yellow, or like orange color. So that this still tells you that, okay, we have a small amount of aldehyde in there, maybe not a big amount of aldehyde. But if it does indeed get converted to like in a really bright red color, that means it's got a very large amount of these reducing sugars that contains aldehyde function groups possibly, or reducing sugars are the one that actually are going to be able to reduce to something else. So the red color that you're getting at the end of the day is typically because of the formation of this Cu2O. So at the end of the day, what you know about the Benedict and the solution test is if a function group contains an aldehyde, it would be in a positive. If it contains a ketone only, it would be a negative. Now, where is its application? So application usually comes in uh, whenever someone is diabetic and the glucose start appearing in the urine sample. They run the Benedict test to figure out if the glucose is indeed in the urine, or and also in to some extent in what concentration. That's because if you look at a glucose actually has an aldehyde function group in there. So if there is a lot of glucose present in the urine, when the urine is ran into within a Benedict test, this would give you a positive Benedict test, or another way of saying it will probably turn the solution um, to a red color. All right, but if it does not contain, it will not turn the solution from blue to anything else. It's just going to stay blue in that particular case. So that's one way of testing the presence of glucose in the urine. And if you have a ketone, as suppose, like in this particular example where fructose actually contains a ketone in there, even though it does have a primary alcohol, are not that easily oxidized by Benedict's solution because it's not a strong oxidizing agent. But if you look at a ketone itself, like in case of fructose, it's going to give you a negative Benedict test. So it probably just stay blue in color. It's not going to change its color from blue to anything else.